How GPS works. Trilateration explained. Have you ever wondered how does the global positioning system work? I guess you did if you're watching this video. GPS uses a method called trilateration. It seems to be widely confused with triangulation, but triangulation requires measuring angles, while trilateration is based upon measuring distances. I'll show you this using a simplified two-dimensional visualization. Let's say we have three transmitters, A, B, and C. They form a triangle. However, they will be able to locate an object not only inside of the triangle, but anywhere in their range. So let's start by measuring the distance to the satellite A. I'll illustrate the measured distance with a circle. I'm not going to show you the receiver yet, because it will be easier to understand how GPS can determine your position without seeing you. So here we are. We've detected that the distance from the receiver to the transmitter A is equal to the radius of this circle. This means that our GPS receiver is located somewhere on it, but we need more information to be sure exactly where. Right now, it can be almost anywhere. Let's now measure the distance to the transmitter B. This should vastly increase our positioning precision. Now, the circles intersect in 2 points. This means that our lost traveler can be in either of these points. We're still not sure where exactly, but the third satellite named C should provide us with an answer. We're measuring the distance to the GPS receiver and… here we are. The three circles have only one common point. And if our detected distances are correct, this point of intersection has to be the location of our receiver. And it really is. Neat. But how does GPS actually measure distances? Let's see. GPS satellites constantly broadcast two pieces of information: their own location and their current clock time. Because the electromagnetic waves that are used to carry this information through the space travel at a speed of light, one can measure a distance using a stopwatch. Well, if it's quick enough to tap it twice in a millionth of a second with precision. Let's say that at this moment all devices, the satellites and the receiver, have synchronized clocks. I'll illustrate the time on a timeline. At the beginning of our timeline, every satellite sends out its own position and time. But before this information reaches the receiver, it's already outdated. I'll mark the arrival times with letters on the timeline. Now the receiver knows where and how much time away from it every satellite is to be found. Multiplying this by the speed of light easily gives us the distance instead of the time. Now, finding the common point of all three distance circles and taking into account the locations of all satellites will give us our own location. And this is how GPS is able to measure distance using a clock. Of course, in real world, this all happens in a three-dimensional instead of a two-dimensional space, so it's a bit more complicated, but the basic principles are the same. I hope you've learned something useful. Thanks for watching!